It's hard to believe that 14.7 billion years ago, our Earth came into existence. Imagine, space. There was nothing but darkness. Then with the colliding of atoms, a big bang occurred, giving birth to our Earth and the Milky Way galaxy in which we're situated. It may sound far-fetched, however, on the smallest of scales, this happens every day. To ensure that a child is born, it starts out with a single female cell. It is then combined with a male cell, and then wham! They collide, and the single cell becomes clusters of cells that later form a tiny human. It's the same concept that gave birth to our universe. Back in the 80s, four cosmologists, Andre Linde, Paul Steinhardt, Alan Guth, and Andres Albrecht, came up with the idea or notion of inflation. After the Big Bang, the universe underwent rapid expansion, and then it slowed for a while. They call this term inflation. It is theorized that there is a residual heat and radiation or dark energy that did not break down from the Big Bang. The combination of heat and radiation caused the galaxy to heat, expand, and cool, then substantially slow down. Some researchers, like Russian cosmologist, physicist Alexander Vilenkin, tried to debate that the universe doesn't stop growing, nor is it slow moving. Instead, it continues to rapidly speed up and expand, creating other worlds in the process, thus the notion of the multiverse. As seen in the diagram, inflation began post-Big Bang due to quantum fluctuations. Next was the afterglow or light pattern that occurred 380,000 years after. Space then entered the Dark Ages, and about 400 million years later, the first stars developed. Then there was the development of galaxies, planets, etc., and the last stage was the dark energy causing accelerated expansion. After that, it just slows down. All of these processes took place after inflation and is called the Big Bang expansion. Keep in mind that inflation happened at a fraction of a second from the Big Bang. It's like throwing a rock into a lake and watching its force and ripples affect the surface layer of the water. This is an example of gravity pushing the universe outward. Two questions remain. Why is inflation so disconnected from the idea of other Earths existing when the same energy created our universe? Why can't it repeatedly happen if dark energy is still present? Vilenkin argues that instead of one explosion, multiple explosions are creating other universes. These bangs didn't just stop or slow down, but it was a continuous process. This multiverse would consist of infinite planets that may be similar to our own planet Earth. That could mean exact copies of us walking around. They could also be very different. Imagine a planet where dinosaurs still roam, or people have evolved to swim like fish. Although it sounds like pure science fiction, it is ignorant of us to believe that we are the only universe with people like us. Space is vast, ever-changing and growing. Vilenkin's theory of eternal inflation suggests that the universe is like a giant bubble, and as it inflates, it causes pockets of space, and within these pockets contain newly formed galaxies. There are other theories that support Vilenkin, like parallel, infinite, daughter, and mathematical universes. Many researchers are running away from excessive models and infinite possible outcomes. They theorize that our universe should be finite because everything in nature is finite, like math, language, etc. Everything is supposed to be comprised of order. Therefore, a multiverse suggests disorder and non-uniformity. So talks of a multiverse will then shatter the inflation theory. So far, mathematics, satellite measurements, along with thermal imaging, have proven that the universe is hotter because of dark energy. However, it's uncertain due to quantum fluctuations in space. We do not have the technology to get out there and see what's happening. We can guesstimate based upon mathematics that the scientists have compiled. So what have we learned? We know that remnants from the Big Bang, like dark energy and radiation, along with the gravitational field, cause this constant expansion. The same energy that produces one universe can create many. The universe is naturally uniform. The reality is none of the theories can fully explain the singularity after the Big Bang. There is no mathematics to support each argument. However, one can dream.